Hey guys, good morning. Good morning. We'll start. I think there are only 27 people. Okay, anyhow, let's start. One second. Can you guys hear me and see my screen?
Yes, yes.
Yes,
Yes.
yes.
Okay. So I was just going through the syllabus actually, like the topics. I think we have already covered what is required in probability and statistics. So this is the course structure. How many of you guys had a chance to look at this? I was just wondering, like, so should we do the important topics? So since we have already discussed expected value and binomial distribution, I think till that point it is more than enough from machine learning and data science perspective. So if you see here, so the statistics for data science is there, right? So what's more important is basics and understanding of linear algebra. So which is your mean, median, mode, standard deviation. Then there is matrix and vectors. Then there is addition and matrices of vectors. The concepts that they have mentioned for probability is fundamentals of probability that we have discussed, which is probability, conditional probability, general addition rule, multiplication rule, Bayes theorem. So this is what generally is being again used in machine learning. Now again, this your Bernoulli, not Bernoulli, binomial distribution, all this is pure probability. Generally, it is not used in machine learning. There is no relationship. So we have discussed probability distributed function, cumulative distributed function, problem solving for probability assignments. So all these we have done. So I'm just wondering, should we start on, I'll complete expected value since I have promised yesterday, so that you guys can finish till basic binomial distribution, what is the expected value. And then I was hoping that we can start with matrices, which is much more important from machine learning and data science perspective. So just let me know, guys. So what do you guys think about this? I think I don't want to spend a lot of time on probability, which is, we have already covered what is more than enough and what is required, so that we can slowly come to the next important topics like descriptive statistics, inferential statistics. These are all important, much more important than other distributions. Data wrangling is very important. So what do you guys think?
I want you to recommend us that is it sufficient based on your experience? Then I think we are good.
Yeah. Yeah, so that's a good point. So I was teaching probability in previous batches also. So what I see is from interview perspective, or let's say the way we work, right? As I've explained in the first three classes or two classes, if you understand basic probability, if you understand conditional probability, and if you understand Bayes theorem, these three are like very important. You definitely need to understand that. That is important. That is part of the course. Then remaining is extra knowledge, right? Till that point, if you understand, that is much more than enough. You don't have to dig into this Poisson and all that. Generally, we don't. I've never used in my career, like, but I've used Bayes theorem many times, like naive Bayes in machine learning. So till Bayes theorem, it is very important, and after that is just your interest or generally extra information. So even in previous batches, I've told the extra things, but I don't think anybody had even practical use of it in the job. Even in interviews, also generally don't ask anything outside of what I've explained till now. So anyhow, we have already started binomial distribution, right? Probability binomial distribution. So let's finish that part completely. So yesterday there was some confusion around expected value, like what is it, how is it related, when does it come, right? So let me finish that part, and then slowly we can start with some other important concepts like matrices and all that, relationship with matrices and NumPy. How are these related? Where does matrices come into picture in machine learning and deep learning? All those things. Is that fine?
Money, how about cumulative distribution? Is that
Yeah,
similar to
cumulative CDF.
binomial?
Yeah, CDF is nothing. It's just very simple. We have discussed that, right? So cumulative distribution function, if you remember. So in case of dice, so the CDF was like this: 1/6, 2/6, then 3/6, then 4/6, and then 5/6, and then 6/6, which is 1. So cumulative distribution is just a property of probability. Any distribution, when you find the CDF of that, when you find the cumulative distribution function of any probability function, so any of the probability function, so the last value will be equal to 1, because the summation of all the individual probabilities, let's say of your probability mass function, all these things we have discussed in the first class. If you refer to the slides, this we have already discussed. So let me just show you. This is PMF. On the top you can see, right, probability mass function. So which defines your, what is the function, like what is the probabilities at each step. And CDF, which means cumulative distribution function, which means that it keeps on adding at each step. So that is the difference between CDF and PDF. So any of the probability function, the CDF, the last, once you reach the last probability or the event, sorry, whatever the possible outcome, then it will become 1. That's the thing that you have to remember. This we have already discussed. Okay, so let me explain expected value, because this is a little bit interesting actually. So then we can move on to matrices. So matrices were very important, and then maybe if time allows, then I'll start a Jupyter notebook and then explain the connection with how we can use matrices inside a NumPy Python package. Okay, so we all can try together. Okay, so this is a concept that I wanted to explain since we had started yesterday. Okay, so let's start this. So let's say you work for a company that pays you a fixed salary of $75,000 every month. Okay, in terms of daily expenses, you spend $2,500. Okay, so every month. So you put the rest in your personal bank account. Also, you start with exactly $0 in your account in 1st of January. So how much money do you expect to have in the 1st of January after 12 months? So how much money, guys? So let's see, every month you get $7,500 and you spend $2,500 you spend. So after 12 months, how much money will I have in my bank account?
60,000.
So I'll have
60,000 plus
60,000.
rest.
Okay, so it's easy. I'll have 60,000. Now there is a twist in this question. So now let's change the example a little bit. Your monthly costs and salaries are still the same. Okay, your monthly cost and salary are still the same, but you also receive a variable monthly pay, right? So that is very common in nowadays, right? So you generally get variable pay. Now these bonuses depend on several market factors which are outside of your control. Okay, so that is very normal. So the lack of control and the uncertainty means that the final amount you receive is no longer deterministic but probabilistic, right? So this sentence is it clear? So what I mean by that is, before, if someone asks you what is your salary for 1 year, you will say $60,000. But now, since there is a component of variable pay every month, you will say that I get 60,000 definitely, but there is some variable pay, so somewhere around I get some money, right? So now you cannot exactly say that, right? So unless 12 months have passed, you cannot exactly say, money, this is the exact amount I will get, right? You have to always give a ballpark figure saying that somewhere around this or 10,000 more or 5,000 more dollars, or let's say my luck is not going well, so I'm just got like $200 all this year, something like that, right? So what happens is this particular figure, which is the annual salary, which was deterministic, meaning exactly before, there is some randomness associated, so that is how it becomes probabilistic, right? So now you exactly don't know uh, what salary you are going to what annual salary you are going to get. Is this point clear? Any questions on this? Any questions till this point? So I think you guys can see the relationship where I'm going from here. Okay. Now, to simplify things, let's assume the following bonus probabilities every month. Okay. So the first, there is $1,000 probability. There is $1,000 bonus. This is all bonus. Okay. $1,000 bonus with a probability of 0.6. There is a $500 bonus with a probability of 0.3, and there is $0 bonus with a probability of 0.1. Okay. Now let's ask the same question again. How much do you expect? You guys see the word change, right? So the word has changed now. So how much do you expect to have in your account after 12 months of work? Okay. Now let's go back. Let's try to do it with the help of probability. So if I go to the next slide, you know you're getting 60,000 from the fixed salary for sure. Okay, but on top of that, you will add an uncertain amount of bonuses. But how much? The obvious answer is that you don't know for sure. And it's true, you cannot know the exact amount with complete certainty, right? Now, for example, it is not impossible that you get very unlucky and receive $0 bonus in 12 months. So is it possible, guys? Of course it is possible, but if you have very bad luck, then you will get $0 bonus for all the 12 months, right? Then what will be your final salary? Your final salary still will be $60,000. Now, what is the probability of getting $0 as bonus for 12 months? So the answer is 0.1 whole power 12, which is 0. Whatever, like this particular value. Now, what is the probability? This probability is extremely low, right? You can see this is 1 out of maybe like 1 million chances, or like 10 million or 1 crore, right? So this is very less probability, right? So this is happening, right? Now at the same time, you can get very lucky and you get $1,000 bonus every month, right? So what happens in that case? Now, what is the probability for that? The probability is 0.6 whole power 12. Now, even this is also the total probability comes up to 0.002, which is 2 out of 1,000, right? Two chances out of 1,000. Now, even this is not as small as the previous one, but still this is also small probability, right? So what is the upper bound here? Now the upper bound is $60,000 plus extra $12,000, which total comes up to $72,000. Now what we have figured out here is, now my fixed salary was $60,000. Okay. Now they have introduced one more concept called variable pay. What they have introduced is, I get extra $1,000 with a probability of 0.6. I get extra $500. I get extra $500 with a probability of 0. I think 3, and I get extra $0, like no dollars from the bonus, which is also a probability of 0.1. As we have discussed, the summation of probability should always be equal to 1, so that is correct. Now that is on the side. Now we also discussed the two scenarios, the two rare scenarios. So we know which is where you get no bonus, which is 60,000. So your total money will be $60,000. What is the probability of that? 1 divided by 10 power 12. Okay, very rare chance, right? Rare, very rare. At the same time, if you are extremely lucky, then you also end up getting $72,000 as the total. What is the probability of that? Which is 2 out of 1,000. So 2 times out of 1,000, you get a chance where you get 72,000 as the dollar. Now, still it is uncertain, right? So still you do not know what. So this is the minimum, and this is the maximum bounds of the salary you get in every year. Now, what they ask or what they say is, can you tell me what is the value or the total value you can expect? Let's say you want to buy a car. So you have to expect some value, right? So you have to expect that value. So this is called your expected value, right? So let me go to the next slide. So since you have summarized the problem already, so what amount do you expect to have in your account by the end of the year after all? We already know the lower bound of the answer is 60,000 and the upper bound of the answer is 72,000. But we saw that both of these extremes have very, very tiny probabilities. So most likely the actual amount will be somewhere between them. So, but is there a value with range 60,000 and 72,000 that's somehow more special than others? The one that you should expect more than the rest? Yes, there is. This is called your expected value. Okay, so the way you will find the expected value is in this particular manner. So the expected value calculation is in this manner. So expected value is nothing but expected value formula is given by expected value of a random variable capital X is given by nothing but, so the value, the actual value multiplied by the probability of that particular value. So what I mean by that is, so the expected value of variable bonuses. So the expected value in 1 month is basically you multiply $1,000 with 0.6, $500 with 0.3, and $0 with 0.1. So the expected value for 1 month is $750. So the expected value for 1 month is $750. If you multiply this with 12, the total amount comes up to $9,000. Okay, so by the end of year, the expected value of your bonuses is 9,000. Okay, so total you can say around I get $69,000 as my total 1 year payment, like expected value. So this is expected value. Now on an average, right? So on an average, this is what you can expect somewhere around this, right? So this is a central figure. Now what does your mean means, which is the center point of this, right? So when you do this, so you get 2, right? So 2 is the center point of this, right? 1 and 3. Now the expected value comes because there is some randomness associated with that, right? What is that randomness? So if you get 0 bonuses, you get expect $60,000. If you are extremely lucky, you expect 70K. But since this is expected value, we need a center point or somewhere in between. So that value is given by 69K. Right? So the calculation is simple. All you have to do is basically multiply this exact value with the probabilities associated with that. Now, does it make it clear like what is expected value, when will it come into picture, and how is it related to probabilities? Any questions on this?
No, it's clear.
Expected value will be calculated.
Your voice is
After,
low.
yeah, expected value will be calculated after any kind of interval.
No,
Or
no. Expected value is whenever there is some probability associated with it, whenever there is some randomness. So if you remember this sentence on the beginning,
no, no. Actually, if
sorry.
we see, if we see the example of rolling a dice or tossing a coin, there is no expected value because there is no interval. But if we see the example, so there is some interval, means interval of 1 month, interval of 1 year. So in this case, there will be some interval, right?
No,
Time span.
no. Wait, I'll explain. I'll finish my explanation then. So let's say if you take a dice. So what is the probability of landing on one?
1/6, and all are 1/6.
All are 1/6. What expected value means is, so let's say if I say expected value of random variable x, where x is basically you're throwing a dice. What it means is when you keep on throwing the dice. Okay, let me calculate the expected value. So the answer is, how do you find the expected value? You multiply this 1 with the probability of that. You multiply 2 with the probability of that. You multiply 3 with the probability of this. You multiply 4 with the probability. So at the end, you end up with 1 plus 2 plus 3 plus 4 plus 5 plus 6 multiplied by 1 by 6. So can you guys tell me what is the answer here? Into so in this case, what it means is, so when you look at this particular example, so the expected value in this case of rolling a dice, what it means is, so it comes somewhere around 3.5. But you can say, Money, there is no 3.5 on the dice, right? So what it means is, when you keep on throwing the dice, so let's say you throw a dice, let's say you throw a dice, let's say you throw a dice, and you keep on doing this, let's say for 100 times, right? So if I ask you, what is the expected number that you see most of the times, right? So the question is, when you keep on rolling the dice, let's say 1,000 times, let's make it 1,000 times, okay? What is the value you see the most, or what is the value you see the most times, most of the times? So that value is actually equal to your expected value. So what it means is, there is no value called 3.5 on the dice, but what it means is you will see the values 3 and 4 more often than the other values, which is 1, 2, 1, 2 and 5, 6. Similarly, in this case, what I meant by expected value is, there is a more chance, if you see this interval, which is 60,000 and 72,000, expected value came up to 69k. So does it mean the person will always get 69k? The answer is wrong. Of course, he can get 70,000, he can get 68,000, but this is a ballpark figure or the central figure, where since there is some probability associated with that, right? If you see this, more or less you will get or end up around somewhere around 70,000, or let's say 68,000. You do not exactly end up around 69,000. So that is, I hope that point is clear. Expected value, the English meaning is, you are expecting somewhere around that, the center value of that, right? It doesn't mean you will always get that part, that amount exactly as your complete bonus. If you are extremely lucky, you might end up at 70,000 also, right? If you are like, maybe market is not doing well, then you might end up at 62 or 63,000 also. But these are like very close to the center value, which is your expected value, which is 69,000.
So can we conclude that our expected value is the means highest sample value, means highest means probability,
Highest probability.
means we are
No,
expecting to get this sample more and more again and again.
no, sample. So sample word is not correct here, right? So sample, there is no word. What do
No,
you
no,
mean?
what I'm saying. So 69k. So in we have 12 months in a year. So
Correct.
maximum means most of the month I will get 69k. Is it like that?
No, no. Every month your salary is only. This is a yearly salary.
But the probability of getting 69k is maximum.
Yeah. So yeah, in that, in one way you can say that, like, because it's the expected value. If you see this guy, let's say if this happens for once, first year, second year, third year, fourth year, fifth year, sixth year, 10th year, like this 10 years, you see this guy, right? Same salary, same variable bonus, everything. Let's say the values, let me put it here. So 68k, these are all just random values that are coming on top of my head. 67k, sometimes 62, sometimes 63, but again 68.5 something, and then again 69, 69 maybe again. So among these, what is the more frequent value, or where you around which value you see, right? So that is basically your 69. So this is close to 69. uh, this is how much I wrote, 62, right? So let's say this is 67. So this is close to 69. So this is also close to 69.
You are saying the 69k is the center value, and
Exactly.
then we can conclude that the other value should be closest to the 69.
Exactly. More close.
Okay, more close.
That's what I'm saying. If you roll a dice many times, 1,000 times, if you keep watching the output, there is a very high chance that you will see more number of threes, more number of fours compared to one, compared to two, compared to five, compared to six. So that is the exact explanation of expected value. Expected value means that when you repeat this experiment many times, right? What is the value that you see most of the times? Right, most of the times, or average, or like more probable times. So that is the expected value. Now is it clear? Any questions, any other questions anyone has? Expected value is not only on interval. Anywhere there is wherever there is a probability, there is an expected value. Okay.
Many one doubt.
Yeah.
The probability that you took, that is 0.6, 0.3, that was chosen at random, right? Like it
No,
was not.
that is already given to you from the business, or let's say that is,
Okay.
yeah.
Like if you change it to 1,000 with a probability of 0.3 and 500 with a probability of 0.6, again that the amount would differ, right?
Correct.
So you cannot say it is an center value.
Yeah, you'll get a new value. So maybe I think 71 or 70. More like maybe you'll get a less value, maybe 65 or 63 you'll get.
Okay.
Okay. Now this also makes sense, right? Let's say I don't know how many people have variable pay, but let's say if you're into sales or anything, generally you cannot exactly say exactly at the end of the month how much money you will end up with, right? So let's say if you're in sales and you make really good deals, let's say March, April, May, so and you get a really good bonuses, but you cannot exactly say money that at the end of the year exactly my money will be this, but you end up saying money 2-3 years I am seeing my salary somewhere around this. I expect my salary. The word expect is important, right? You cannot exactly say. Does it mean you will get that exact number? No, you get somewhere close to that. So that is your center point whenever there is some probability associated. Okay. So this is your expected value. Actually, these slides were not there, so that's why I was not able to explain yesterday. Now, if we go back to our binomial distribution, now the expected value has a formula. So that formula is given by NP. Okay. So what it means is, let's say if you flip a coin 20 times, so N is 20. And what is P? P is the probability of success, which is basically 1 by 2. Okay. Now the expected value of the X means it's a binomial distribution. Binomial distribution is given by this particular formula. So expected value of X, capital X. So capital E of X is given by NP, which is equal to, let's say if it is 20 and then it is 20 times half, which is equal to 10. Okay.
Can you explain it once again? This thing.
Yeah. So, so expected value is, in simple terms, this is the mean of your what do you call mean of your probability. Like whenever there is a probability, so mean of this is generally called your expected value. Right now, if you understood this discussion that I've explained here, so what, and if you understood the discussion that I've explained in the dice, which is 1, 2, 3, 4, 5, 6, what it means is you can expect. So let's say if you have 20.
No, what is N here? Is EXNP? What is N?
N means the number of times you flip a coin. Let's say if you flip a coin completely, total number of times is 20. That is N.
Okay.
Okay. You remember, right? In the example yesterday, I've explained the formula was N C X, then probability of success whole power X, and probability of failure, which is 1 minus P whole power N minus X. We have solved some problems yesterday, N minus X. Okay, so this is the formula for binomial probability distribution. The let's say if you flip a coin 20 times, what is the probability of getting 3 exact heads? So n is 20, and this is your x is basically 3, and the probability is basically 1 by 2. Okay, now this is where I would say that this is more than enough. I think we have already discussed many things, so this is still, I would say, extra information for you guys. So I think it's a good idea to start with the uh, linear algebra matrices and vectors. Okay, so that if I get some chance, I'll try to see if we can do some hands-on. Okay, any questions on expected value? I hope you guys got the idea, the basic general idea. Like in real life also you can explain that. Okay, so 1 second. So, introduction to statistics. Any questions on basics of probability? I've shared the URL in the WhatsApp group. You guys can try some of the problems. There is answers also. If you guys need any help, you can let me know.
We didn't finish with binomial, right?
Yeah, it's not so this much information is enough. So that's what I explained in the beginning, right?
Okay, okay,
So that is not even there in the new course actually.
okay.
What I'm explaining is actually 2 years old course.
Okay.
1 second. Okay, so let's start with matrices. Matrices is very important from machine learning perspective. So before I start with matrices, any idea like what is a matrix? Did you guys learn about NumPy?
Yes.
So what did you guys learn in NumPy? What functions? What is it useful for?
Matrices are basically n-dimensional arrays.
Okay. Dimensional arrays. Okay.
It's including rows and columns.
They are the collection of vectors.
They are what?
They are collection of vectors.
Collection of vectors. Okay. So what is the difference between a NumPy array and a Python list?
In Python, basically heterogeneous data can be there, but in matrices, but in NumPy, homogeneous data will be there. No, but the data, yeah, homogeneous.
Yeah, this is one of the interview question, guys. So NumPy arrays can only contain one data type, whereas Python list can contain strings, integers, values, doubles, list, floats, everything it can contain. Right?
Yes.
That is important to remember. Python list and NumPy array. Okay. Now, so is NumPy array faster than Python list? Anyone knows this?
Yes.
Sorry.
Yes, it is faster.
Yes.
Are NumPy array faster than Python list? So I can actually create both of them.
Yes.
So I can create L equal to
Faster in terms of what accessing or operations?
yeah anything actually. If you run a for loop or if you do any multiplication or anything for smaller, so for the size, if the size is small, you will not see a significant difference. But let's say if there are 10,000 values, then you can start seeing slowly Python is slow. I mean the lists are slow. Let's say let's say if you're running a for loop, or let's say if you're multiplying every number with 2, anything that involves touching all of the values in the numpy array. So how do I create a numpy array?
np dot array,
np dot array.
And then
and then the data type, data what we are adding into that.
okay, good. So this is your np dot array. So both these let's say this is Python list, this is numpy array, very small, not a big difference, not a big deal at all. Python and all the modern laptops can handle this. But let's say there are 10 lakhs values, then you will see some slowness here, and this would be still faster. The slowness is because Python doesn't know what is the value type present in this. But here, since it is numpy array, Python already knows that these values are, let's say, float, or let's say integers. So it doesn't have that extra time to figure out, or it doesn't need extra time to figure out. So generally, this is faster. Okay, that is good to know, general information. Okay, so let's come back to matrices now. So matrices are everywhere. Can anyone give me an example, like a real life example where matrix is present? Like matrix is basically a collection, right? So or organization, you can say, right? So there's so many real life examples. Any example that comes to your mind?
Cricket scoreboard.
Cricket scoreboard. Okay. Okay. Any other answer?
The screen, I mean the pixels.
Yeah, that's a good answer. Okay. It's a little high level, but good. Any other answer? Any simple answers? So let me ask like in this way. Any simple things that come to your mind? Right. So let's say in a class, let's say if there are 6 students. So let's say student 1, student 2, student 3, and student 4, student 5, and student 6. And this is where the professor and the board is. Right. So this is a matrix, right? So this is just an arrangement of 6 people in 2 rows, row number 1 and row number 2, and 3 columns, column number 1, column number 2, and column number 3, right? Let's say if you go to a movie theater, so this is the screen, and you have rows number. Let's say if you book a movie, there's A, B, C, and then let's say D, C, D. So there are like, let's say 10 people, and so let's say 10 people here, 1, sorry, 1, 2, 3, dot, 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 let's say 10. Now, what is the matrix here? How many rows and how many columns are there?
3 cross 10.
4 cross 10.
3 cross 10, na?
ABCD.
Sorry?
ABCD, right? How is it 3?
Acha, CD also. Okay, yeah.
4 rows and 10 columns. Okay, so this is a very simple introduction or idea behind matrices, right? So whenever there is arrangement, right? So when you can arrange values, or when you can arrange in the form of rows and columns, there is a matrix associated with that. Okay.
So I could say that tabular data also.
Yeah, every tabular data is a matrix. So that's what internally happens in your computer actually. So all of these matrix multiplications will be going on. So when you guys have done pandas, have you guys learned about pandas?
Yeah.
Yeah.
Right. So the first step is you create a data frame, right? So pd dot CSV read CSV or something like that. So what it creates is a data frame. So what data frame is ultimately is a matrix, right? So when you do, let's say this is your df1, and let's say there is df2, and then let's say this is df2. So when you do concatenation or any other operations, what is happening is this row wise operations are happening. So this is coming here, this is coming here, this is coming here. The resultant will be a longer one like this. Right? So everywhere inside your computer, whenever you are dealing with machine learning and deep learning, all the operations that come inside are in the computer or inside NumPy, Pandas, TensorFlow, all of them are matrix multiplications. Okay. So it is actually, it will become little bit high dimensional. So I'll explain in few moments. But let's understand the basics first. Then we can go to the remaining things. So this idea is clear, right? So when you get a matrix, so it is nothing but arrangement of numbers, right? So rows by columns. Okay. That is called your shape of your matrix. Okay. So when I write a matrix which is A 3 cross 2, what it means is there are three rows and two columns. So there are 3 rows and 2 columns. Okay, so this is important. So you need to understand what is the shape of the matrix, right? So whenever a matrix is given, you need to know what is the shape of the matrix.
Mani, I have one concern. Means before going to that matrix, I just want to know that in day-to-day activity, means apart from that Tableau data, yeah, Tableau data is there that I can understand. Ki, files are there that we have to read by, that we have to understand what data it contains. But apart from Tableau data, where that matrix coming into the picture for as a data science profile.
Okay, so let's say if you are working with the image, okay, so each image is composed of pixels, right? So let's say this is the image you took. So let's say this image is 28 cross 28. Okay, now each pixel is basically this much, right? So 1 pixel, 2 pixels, so which means is there are 28 pixels here, correct? And there are 28 pixels here. Now is this a matrix? Is it
No, these pixels are in corner or it is spread over all
all?
over.
Your
Acha.
image is made up of pixels. If you go very close to your screen, TV screen or laptop, you can actually see pixels like dot 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 dots, right? So what I'm trying to explain here is from a practical standpoint. Let's say any image you get, if you are working on any image, this is what you get. But what you end up doing is you do some matrix transformations, right? So let's say you make this as a very long 764 pixels, right? So 764 is basically 28 multiplied by 28. So what I'm doing is taking this pixel, keeping here, taking this pixel and keeping here. Why I'm doing this, you'll know in the next classes. Taking this and keeping here. So what I'm doing is, this is matrix number 1, and I'm converting this into a different shape of matrix, which is matrix number 2. Why I'm doing this, all you'll learn in the coming classes, but you guys can understand like how understanding of matrices is important when I'm converting this to this particular matrix. So both of them are matrices. The shape of the matrix here is 28 cross 28. The shape of the matrix here is 1 cross 764, right? So these are the matrix transformations that you do generally in the practical data science. Is it clear? There are many examples I can give. For example, let's say if you're working with text. So text meaning, let's say if you have word I am money. Okay. Now you do not work with this sentence in this form, right? So what you do is you create a vocabulary. So let's say the vocabulary is something like this. So the vocabulary is I am money, and then let's say hi, and then buy. So these are the words in your vocabulary. So what you do is you assign numbers to this. So let's say 0, 1, 2, 3, 4. So let's say I am money is one sentence, sentence number 1. And then you have another sentence, which is sentence number 2. Let's say hi, bye. Okay, hi, bye. Now what you create, let's say there is another sentence, and sentence number 3, which is basically called I hi, something like that. I hi. Right? So what you do is you convert these text into numbers. Basically, you convert them into vectors. So what is the vocabulary? I am money, hi, bye. So basically the answer will be something like 0, 1, 2, and then again, there will be nothing here. Something like that. I hope you get the idea, right? So basically what I'm trying to do here is, so you can keep this as, let's say, capital X and capital X. Now this is sentence 1. How does sentence 2 look like? This is capital X, this is capital X, this is capital X, then there is 3 and 4. How does the third sentence? So this is sentence 2. How does the third sentence look like? Third sentence will look like 0, capital X, capital X, 3, then capital X. Now, given 3 sentences in NLP, natural language, you are able to convert this whole thing into a matrix form so that you can do some operations after this form. So this will be used for your input as your neural network and all that. So matrices are everywhere. Like once you keep on, once you learn more and more about like other applications, you will understand better. Is it clear? Did I answer your question? Like
Yeah. Thanks.
everywhere you will create matrices. So that's the thing you can remember. If you don't want to remember all this, generally everywhere you create matrices and you work on them. Okay. So shape is important. So what is the shape of a matrix? So let's say if there is, so what is the shape of this matrix? The shape of this is, it has 2 rows. So 2 rows cross, how many columns are there? 1, 2, 3, 4. So 4. So everywhere shape of the matrix, you need to be, you need to know how to calculate the shape of the matrix. Okay. So let's take simple operations. So let's say if there is a matrix like this, 1, 2, 3, 4. So there is this matrix. Okay, so this is matrix A and this is matrix B. So can you guys tell me what is the answer of A plus B?
1, 4, 2, 5.
So 1,
4,
4,
2, 5.
right? Very simple. Like you add all these, corresponding values, right? So similarly, you have A minus B. You subtract them. Okay, so these are very, very simple basic operations you can perform on your matrices. Okay, now there are some notations that you have to remember. If your matrix looks like this, if your matrix looks like this, so this is called a row vector or row matrix. So vector means there is only one dimension. So row vector. What it means by that is basically the row is fixed, like there is only one row, but there are many columns. There are many columns. This is your row matrix. Sorry, row vector or row matrix. Generally, they call it vector because there is no other, you can forget about rows. They know that only there is one row. What you do is you focus on the columns here. Okay? So there is one more notation called column vector. So this is column vector. So column vector has only one column. So let's say this is 2, 3. This is your column vector and this is called your, uh, uh, it has only one column. Right? So this is your row vector and this is your column vector. Okay, some notation. Now, what is a square matrix? So square matrix is nothing but whenever the number of rows and number of columns are equal. So let's say if it is 1, 2, 3, 4, 5, 6. So what is the shape of this matrix? Shape of this matrix is
2 by 3.
2 by 3.
Is this a square matrix?
No.
If I make this like this,
Yeah.
so the shape of the matrix becomes 3 by 3, which is a square matrix. Okay, you can find the square matrix like this.
That row vector can be, or we can call it a list also. Because
List, we are not talking Python anyone actually. We'll only discuss, yeah, it is list, but since we are discussing matrices, right? So it will be row vector. Like you can call it as vector generally, or NumPy array. You can say that is a more appropriate, right? So NumPy arrays can be, this is NumPy array, this is also NumPy array, and this is also NumPy array. List is only this one. Only list applicable is only here. This cannot be a list. This cannot be a list. Okay. So we have discussed what is a matrix, how do you add two matrices, how do you subtract matrices, what is a column vector, what is a row vector, and what is a square matrix. So square matrix is basically wherever the number of rows and the number of columns are equal. That is called your square matrix. Okay. Now there is a concept called diagonal elements. So diagonal elements are these. So this is called your diagonal elements. Okay. So that is general. I'm just giving you some convention about matrices. Okay. Now these are all not so much required.
What was that leading diagonal?
Yeah, you can read about this. So this is not. This is all. This is. So what I'm explaining right now is just the important things. Where did you see that? Yeah, diagonal is basically leading diagonal. The word is different. That's all. In a n by n square matrix A, the lead diagonal or a principal diagonal is the northwest to southeast collection of elements. That's whatever I've highlighted in the black. So this is called your diagonal elements. I just didn't add the word leading diagonal. That's all.
Yeah.
There's so many words people use in many different books, so you don't have to worry about it. But the concept is same. Okay, so row vector, column vector, column vector, square matrices. In square matrices, the thing you have to remember is the number of rows and the number of columns should be equal. Addition of the matrix, subtraction of the matrix. Okay. Now, one more thing is this is important. So let's say if you define a matrix like this. Now, when I ask something like this, so can you tell me what does it mean? By the way, matrices are represented by capital letters like A, capital B, and each individual element is represented in a small letter like small a. Now, what it means? Can anyone tell me what is the value of A12?
-1.
First row, second column.
First row, second column.
Yeah.
A12 is given -1 here. So let's say if it is A 23.
-2.
So the way you figure out is second row and the third column. So you need to understand how to extract the values from your matrix. Right? So all these are very simple, but I'm just trying to explain, give you some context.
A matrix is zero based or one based?
Matrix with?
Zero based index or one based index?
No, it is one only. Okay. So here we say A11. Actually, we don't say A00. Here you can say, right? You can see here, right? He's starting from A11. That's a good question. And it starts from A33. Okay.
Okay.
A good point, actually. Now, okay. Now, so some more linear algebra. For example, so what is this? So let's say if it is so what is the value of question mark here?
1.
1.
Right. So one is your identity in numbers. So one is called identity. So what it means is if you multiply anything with one, you get the number back. Right. So identity. So in case of matrices also, they also have identity matrix. Right. So identity matrix is anything you multiply it, anything you multiply with that, you get the matrix back. Okay. The general idea is, let's say if the A matrix is this, so let's say A is something like this. So 1, 0, -1, and let's say 2. The identity matrix for this is something like this. So identity matrix is in this particular manner. So 1, 0, 0, 1. Okay, all the diagonal elements will be 1 and all the non-diagonal elements will be 0. Okay, so this is called your identity matrix. So if you multiply this A with I, you will get A back, A matrix back. Okay. Now, how do we multiply? Right. So that is important. Right. So before that, so identity matrix. So zero matrix is nothing but you have all the values as zero. Identity matrix for 2 dimension is basically this. 3-dimensional matrix is basically in this particular manner.
Identity matrix should always be a square matrix.
Yeah, identity matrix is always a square matrix. Yes, answer is yes. Okay. Now, where are we? So transpose. So can you guys tell me what is the transpose of a matrix? Anyone knows transpose?
That row will be converted to column value and column will be converted to row value.
Right. So transpose is nothing but, so let's say if your matrix is something like this. Okay. The transpose of this will become, so the rows will become columns. The columns will become rows. Okay. So this is your A matrix, and this is your A transpose. Okay. Now, can you guys think of a practical application where transpose will be useful? This is an interesting application you can think.
In the Excel data.
Sorry?
In the Excel, we used to convert the names into rows into columns.
Yeah. In Excel, we use. Can you think in case of photos?
A rotation of images.
Yeah. So generally, when we take a picture, sometimes we keep the phone like this, right? So, but what we want is, we want the image again like this. It will be like this, but the picture will come here. So this is basically a transpose of a image, right? So basically, you're making the columns as rows here. Right? So this is a general. We have all tried that, right? So whenever we take a photo of a landscape and we want to flip it in 90 degrees, so that is basically your transpose of a matrix of pixels. Okay. So matrices have a lot of relationship actually. Like we can we can connect to a lot of real life examples. Okay. What is the value of this? So let's say if the value of A is equal to 1, 2. So what is the value of A transpose? Whole transpose.
A only.
Right. So this is nothing but we will come back to A. Now let's discuss some of the interesting applications. So I don't know how many people know this. So let's say if you want to multiply two matrices. Okay, so let's say there is a matrix A and let's say there is a matrix B. So there is a condition that you have to fulfill. So one condition is there that you have to fulfill. Then only you can one condition. So to fulfill.
The column number of the first matrix should be equal to the row number of second matrix.
Right. So that is the property that you have to fulfill. So let's say A matrix has a shape of M cross N. Okay. And B matrix has a shape called R cross P. So what it means is the matrix A has M rows and n columns. And matrix B has R rows and P columns. So what it means is this number N should be equal to the number R. Okay. If these numbers are equal, then only you can multiply A cross B. So this is one important property you have to remember. For multiplying two matrices A and B, it is very important to know, this is the precondition, like this condition has to be fulfilled. The number of columns of the first matrix A should be equal to the number of rows of the second matrix. Okay, is this point clear? So this is, if this is true, then only you can multiply A and B. Okay. Now, if your resultant matrix is C, So let's say if your resultant matrix is C, the shape of C will be equal to M cross P. Okay. So the resultant matrix, whatever the matrix you figure out or find after multiplying, so let's say the answer or the multiplied answer of this will have a shape of M rows and P columns. So M rows is basically the number of rows of your first matrix, and P columns is the number of columns of your second matrix. Okay. So this is very, very important. Whenever you want to multiply two matrices, the first thing that you have to understand is the number of columns. The number of columns of the first matrix should be equal to the number of rows of the second matrix. And the second point that you have to remember is whenever you multiply, the final matrix that you get will have the same number of rows as the first matrix and same number of columns as the second matrix. Is this point clear for everyone? Any questions, any doubts?
It's clear.
Okay. So let's take one example and then you guys will understand better. So let's say if I define A, let's say 2, 3, 0, 1. Let's say B is 1. What is A cross B? Can you guys try this? Do you guys know how to do this? So let's say first is I have to check the compatibility, like are they allowed to multiply. So what is the shape of this? The shape of this, it has 2 rows and 2 columns. What is the shape of this? It has one row and 2 columns. So the answer is I cannot multiply this, right? Let's say if I undo this and I use this. So what is the condition now? So the shape of this is again 2 by 2. The shape of this is 2 by 1. Can I multiply? Yes. So this 2 is equal to, this 2 matches with this 2. And the final answer will have a matrix which has 2 by 1. Okay. So the way I can multiply this is, so let's say I have 2, 3, 0, 1 multiplied by this particular matrix which is 1 and 1. Okay. I know that the final matrix will have how many rows and how many columns? What will be my final output? Like what is the shape of that?
4 rows, 1 column.
2 cross 1.
2 cross 1 is the final shape of the matrix. I don't know the matrix, shape of the matrix, which means I have 2 rows and 1 column. So let's say this is value A and value B. So the shape of this final matrix C is equal to 2 cross 1. So till this point, I have some idea what to do. So the way I do that is I multiply this with this, right? So what it means is 2 times 1 plus 3 times 1. Okay, so the value of A is equal to 5. Okay, for finding the B value of B, I multiply this with this. So basically you multiply rows with columns. Okay, so you do 0 times 1, 0 times 1 plus 1 times 1. So the answer is 1. Okay, so let's take one more example. You guys try it and tell me what is the answer. So let's say the value of matrix is 2, 3. Can you guys tell me what is the matrix multiplication of these two? So let's say this is A, and let's say this is B, and I want you guys to tell me the answer, which is C. First question is, can I multiply these two?
Yes, can multiply.
So the shape of this is 1 cross 2. There is 1 row and 2 columns. So the shape of this is 2 cross 2. So money, I know that the middle elements are same. So this is same. So I can multiply. Now what is the shape of the final matrix? The final matrix shape is these two numbers, which is
1 cross 2.
1 cross 2.
1 cross 2.
So how does a 1 cross 2 look like? 1 cross 2 looks like A and B. What I want you guys to tell me is the values of A and B.
2 and 3.
3. So the answer is 2 and 3. So looks like you guys got the hang of it. So let me make it a little bit tricky. So what is the matrix multiplication of this? How about this one?
That's 7
Minus 1.
minus.
So I hope you guys are getting the idea, right? So this is what you don't do all of this by hand, but this is what is internally happening in your NumPy arrays, or whenever you are doing high level function. Internally, all this is going on inside your computer actually. So it's very important to understand like how matrix multiplications, all these are happening.
4 is the answer.
1 should be the answer.
No, this is -1 and this is
2. Oh, okay.
4. 4, right?
so the answer is 4. How many people are saying answer is 4?
Yes, 4.
Yeah.
Okay, so
Minus 2 plus 6. 4.
yeah, so this is a, what will happen is, so can you guys see an interesting application here? So what do you understand from this? 4 is the answer, that's fine. But can you think a little bit some more and then tell me, Mani, this is what seems interesting here. What is the interesting point here?
Data compression.
Yeah, so that's a good point. So what I'm saying is, Mani, there was a matrix which was of shape 1 by 2. By multiplying with another matrix which has a shape 2 by 1, I'm essentially actually compressing all this into one number. Right? So you guys remember zip file, right, in your Windows or your Mac, or let's say Ubuntu, wherever. So if there is a folder, let's say this has 9 MB, right? So when you zip it, actually it becomes somewhere close to small, and then it becomes, let's say, 2 MB or something. Right? So this is basically called your compressing, right? So but when you send it in email and then you open it, it actually again uncompresses back to 9 MB, right? So this is one of the application that you can think or remember that is useful. So whenever you want to compress data, so there are some options that you can use in matrices where if you multiply with appropriate shape of the matrix, you generally can compress the dimension from, let's say, high level dimension. There were rows and columns. Here there is only one row and one column. Right? So essentially a number is remaining. Right? So this is one of the technique that you can use in matrices called data compression. Right? You can compress the data which was present in two matrices into one number. Okay. Now, in the similar fashion, so what is the answer? What is the answer of this? One second, let me think. Yeah, what is the matrix multiplication of these two matrices, A and B? Think and do it.
2 cross 2 will be the resultant matrix.
Okay. So the shape of this is 2 cross 1. The shape of this is 1 cross 2. Mani, the center values are equal. So I can multiply this. Yes, answer is yes. And what is the resultant matrix? The resultant matrix has a shape of 2 by 2. So which means it has 4 values, A, B, C, and D. So what you have to figure out is you have to figure out the values of A, B, and C, D. Can anyone tell me that?
1 minus
1.
1, 2 minus.
Yeah.
Minus 1,
2 minus 2.
2 minus 2. So anyone has any confusion on this problem? This is the tricky one, that's all. If you understand this, then it's fine. Any doubts, any questions on this? So as we can compress data, we can also explode actually. So here there are two vectors. These are basically vectors. So this is a vector and this is a column vector and this is a row vector. But I was able to get a matrix out of it. Right. So at the same time, these were vectors and this is actually called scalar. Scalar means a number, just a number. Right. So this is a vector and this is also a vector. But multiplying these two vectors, I ended up with a scalar. Sometimes you can end up with a scalar. At the same time, you can also end up with a matrix. Okay, any questions, any doubt, confusion on this? So these concepts are important. If you understand this one, then it is fine. Okay. So remaining again is might be theory and some small things. So you don't have to worry about those things. Okay. So let me just check if I have finished. Okay. So let's, you guys have installed Jupyter Notebook. Have you all installed Jupyter Notebook?
Yeah.
Money will division will also be in the same similar manner.
Yeah, all of them will be similar. Subtraction, division. Wait, what division you mean? The
Matrix division.
1 second.
So you showed us matrix multiplication, so the matrix division will be the same.
You mean, let's say A is this. So there are two types of multiplication actually. So for example, there is this one. Okay. Now, okay. So I don't remember the name of it. So, but there are two types of multiplication. Let's say there is
Dot product, cross product.
so dot and cross product. So I don't remember what is what. But so what happens is there is a row wise multiplication. Let's say this is 1, 1, and let's say this is 2 and this is 3. So what it means, what I mean by that is there is an element by element multiplication. I'll come up with the exact words. I'll explain you maybe in the next class. So this is one way of multiplication, right? I don't know what is that word called. So you multiply this A11 with the A11 of B. You multiply 2 with the 1. You multiply 3 with 2 and you multiply 4 with 3. So this is what one way of multiplication. Okay. What we have seen is called, I think, cross product, if I'm not wrong. So this is another way of multiplication where we check the shape of the matrix 2 by 2 and here also 2 by 2. The final answer is also 2 by 2. So where we multiply this row with this column and we multiply this row with this column. Okay, so you need to, so division also, generally there is row by row division, basically 1 divided by 1, 2 divided by 1, and let's say 3 divided by 2 and 4 divided by 3. So what I've explained is basically a special case where you're multiplying two matrices in their multiplication form. I think it is called cross product. What I've defined, what I've explained in like A plus B, A minus B, right? So A star B, so let's call this as A star B, and A divided by B. So all of these are element by element. So element by element. So which means A11 will be added to A11 or subtracted or divided. What I've explained is the other thing that I've explained for so long is A cross B. This is called A cross. Right? So this is basically your matrix multiplication. So generally we only so these are called matrix transformation actually. So these are matrix transformations. So generally you do matrix transformations where you actually do this A plus B, A minus B, or A times B, or A divided B. But most of the times your focus will be on multiplying two matrices, something like one data frame, and then you do some operation and then this becomes something like this, like a vertical one, something like that. So these are all called your cross products. Okay, and think all these are called your dot products and element by element operations. Okay, is it clear? So there are two types of multiplying actually in matrices. You can multiply element by element, or you can multiply matrix by matrix. Okay, so division comes by element, right? So there is only special case for matrix multiplication, which is one case is row by row, which is basically you multiply row by column and all that, whatever we have discussed. And there is also an option for multiplying by element by element. So basically you multiply 1 by 1, 2 by 1, 3 by 2, and 4 by 3. So that is also there.
So other type of division is not there, cross, like you told, cross multiplication, a row into column.
No,
So
no,
division-
that is generally not there. So generally you don't do these operations as much. You mainly focus on this one.
so once we have done multiplication, we can't get back the original one, is it?
Once you multiply,
once you do a cross product, then if you want to get back the original one, so since you're telling division is not possible, so I was asking.
Okay, that way. Okay. Not possible. Okay. In the first place, you already have A and B, right? So for multiplying A, B, you already have A and B, right? Why do you want to get it back?
No. So okay, for a use case, like if I want to compress a data, I'll multiply that, I'll send the product to other machines. There I have to get back the original one, right?
I understood what you're saying. Okay, so there is one more thing that I forgot. That's a good point. So there is an inverse of a matrix. Okay, so A inverse. Okay, what A inverse means is, so let's say you have this matrix AB. Okay, now you can do A inverse here, multiply on the left hand side by A inverse, you end up with a matrix called B. Okay, now let's say if your matrix A equal to this form, so the division is inverse here, right? So there is element by element division. Sorry, that is my mistake. So let's say if A inverse, how do you define A inverse for a matrix A? Let's say if your matrix A is in this format. So let's say A, B, C, D. So the inverse of A inverse is given by 1 by AD minus BC. Okay. And then you D, if I'm not wrong, DA minus B minus C. So the inverse of A is given by this particular matrix. So let's say if we have a compressed matrix which is AB, all you have to do is give them the inverse. So they will multiply this inverse on the left hand side. Okay, basically you multiply A inverse with AB in this manner and then you get back B. Okay, is it clear? So this thing I forgot to explain. So matrix also has inverse. So inverse is nothing but, so how do you find inverse? So the way you can find inverse is A multiplied by A inverse, inverse of a matrix, equal to A inverse multiplied by A equal to identity matrix, equal to identity matrix. Or you can directly use this particular formula. So let's say if you have a 2 by 2 matrix, I think this might not be perfect. I'm just writing this with the memory. If there is a change, just follow whatever you see online. So inverse of a matrix is generally given by 1 divided by AD minus BC. Okay, AD minus BC. And then you switch the diagonal elements. So DA, and then you negate the remaining non-diagonal elements, which is basically minus B and minus C. Okay. If you find this particular matrix, then if you multiply this matrix with A, you will end up with an identity matrix like this. So 1, 0 and 0, 1. Is it clear now? Actually, I didn't understand clearly your doubt when you meant inverse. I thought element.
Yeah, I was asking the same thing for division, like we are multiplying.
Yeah. Actually, it's not division here, it's inverse actually. That's the word. Okay. Division generally refers to the element by element. Okay, is it clear? So for example, in case of three-dimensional matrix, this formula will be more complex and different, right? So I don't remember that. I remember two-dimensional matrix inverse. So that's why I've written here. Okay, so once you get the inverse, you can find the, you can basically divide or multiply, right? So inverse is nothing but multiplication, right? So in algorithm, in natural, sorry, not natural, in algebra, there are only two operations, which is actually there is only one operation, which is addition. Okay, so 3 plus 5. Okay, let's say 2 times 3. The way you can write this as 3 plus 3. Okay, let's say 3 minus 5. So you can write this as 3 plus minus 5. Now, can anyone tell me how you can write 6 divided by 2 in terms of addition? So this is addition. This is subtraction that I've written in terms of addition. The multiplication also I've written in terms of addition. Can anyone tell me how I can write division?
6 plus inverse of 2.
Plus inverse of 2.
I don't know. Maybe.
Yeah, so you're almost there. 6 plus, how many times you have to do minus 2? So you do minus 2 3 times until you get 0, right? So that is division. Okay, so like this in natural, in normal numbers or linear algebra, every operation actually internally is actually a addition operation. Okay, so what I mean by 6 minus 6 divided by 2, answer is 3, is you do 6 minus 2, you do 6 minus 4 minus 2, and you do 2 minus 2, then you get 0. Then you get 0, correct? So how many times you subtracted? 3 times. So the answer is 6 divided by 3 is actually 3 times. Okay, but essentially minus is again plus times minus 2, right? So again this is addition. So technically division can also be written as addition. So the reason that I'm explaining this addition, all this in here is when you want to find an inverse, right? So when you want to find an inverse, the way you find the inverse is basically you remember this property, right? So A times A inverse is equal to, so what you do is, let's say you have A, so let's say A, let's say A is 1, let's say 2 and 3, 4, and A inverse, let's say if it, A inverse is, let's say, someone is unmute, can you mute yourself? Do you have a question? Is there a doubt? Yeah. Right, so let's say this is your A, so let's say 1, 2, 3, 4. Let's say you want to figure out A inverse, right? So let's say this is A, then B, then C, D. Right? Then you know that multiplied by this is equal to I matrix. So let's say this is 1, 0. Right? So all you have to figure out these 4 values, right? So you multiply this with this, you multiply this with this, you multiply this with this, and you multiply this with this, and then you equate this to 1, and you equate this to 0, and you equate the other one to 0, and you equate the other one to 1. If you solve that, you will get the values as A, B, C, D. So basically this is A, and this is your inverse of a matrix. I hope this is clear. I think I missed this part, but there's so many things actually. Matrix you can learn, but the basics are these, right? Inverse, transpose, column vector, row vector. What is a matrix? What is the shape of a matrix? How do you transpose, right? How do you find the identity matrix? What is a square matrix? What is the diagonal elements of a square matrix? Okay. Any questions on this till now? Whatever we have discussed.
Determinants.
So determinant is, can you mute yourself? Yeah. So determinant is there. So I don't remember the formula exactly. Determinant is basically the actual value of the matrix, right? So let's say if you want to get a scalar value of a matrix, then you can find the determinant of the matrix. So let's say let's say if we have a two-dimensional matrix A, B, C, and D. So the determinant is denoted by DET. Okay, so let's say this is matrix A. So determinant of A is given by AD minus BC. So this is a scalar. Scalar means a number like 1, 2, 3, 4. So this is a scalar. So there is determinant, there is trace, there is so many properties are there, right? So generally, if you remember all these basic ones, it's more than enough. Okay. So determinant for three-dimensional will be different again, right? So all those things you can read up. So that is not a problem. So what I wanted to do was actually do some hands-on so that you guys can figure out like, 1 second. See, can you guys start Jupyter Notebook so that we can do some hands-on? So you guys use Jupyter Notebook or Jupyter Lab, or you guys, have you guys installed this in the first place?
Which one, Jupyter Notebook or Lab?
Yeah, Jupyter Notebook. Like, how did you guys install that?
Through Anaconda only. It is installed.
Okay. You guys installed this one, Anaconda Navigator.
Yes.
Yeah.
Okay. So you guys can start using Jupyter Lab. Okay, I'll explain the advantage of that. Jupyter Notebook is here and Jupyter Lab is here. So this is how a Jupyter Lab looks like. Okay. So this is like a full ID, right? So say if you have directories and all that, right? So if you remember, let me show you both. Have you guys, anyone used Jupyter Lab before?
Yeah.
No.
I'm
So this is how your typical Jupyter notebook looks like. Right? So let's say if you want to go back to downloads, so I have to click here. Then let's say if I open this part, then I don't, then opening the files is a problem. Let's say I have to go and then do file open, and then again I have to go here. So that is one of the downside of Jupyter notebook. So Jupyter Lab, on the other hand, so you can actually navigate the folders here. So let's say these are all the folders that I have, right? So let's say if I go to documents, let's say I can go to desktop, right? So this part doesn't change. So whoever doesn't know this, I'm just explaining for you guys. So let's say if I am working with documents, let's say documents, and then so let's say if I'm working with, let's say work, so I can keep on changing between lot of folders, right? So let's say on the top I can open a Python file like this. I can open a Jupyter notebook here, right? So like this, I can write all of the files. I can also open this one, right? So Jupyter notebook. Okay, so these are some of the advantages that I've seen. So I've been using Jupyter Lab. So I would suggest you guys also to start using Jupyter Lab. It is nothing different. The UI is a little bit different, and the it's a little bit faster than Jupyter Notebook. Okay. Now some more
all shortcuts, everything is same, right? Everything.
all of them are same. Now some more things. I don't know if you guys know this. So these are the notebooks. This is where you can go and see. These are the notebooks that are running, right? So let's say I can do shutdown, shutdown, shutdown. Okay. So similarly, you can do this here. Right? If you click on this, I just shut it down. Okay. So there are so many other options that you can see here. So I would advise you guys to start using Jupyter Lab. Okay. So you can refresh here. You can add a folder and all that. All those operations you can do. Okay. So what I wanted to do is, so let me create one folder here. Meanwhile, all of you guys see this in your laptop. Can you guys open this? Although I'm hoping that you guys can open this in your own laptop. Any problem before so that we can address this in the beginning, and then we can. And everyone is able to open this. This screen, everyone is able to see in your own laptop.
Yeah, but in launcher, this notebook, console, others, these things are coming.
In launcher,
Means in right side where that import necessary packages is written over here in your window. Uh, but
That's
for me, it's
the
like launcher, and in that top of the below, notebook, console, uh, these things are written.
We don't have the file.
yeah, you are seeing this one, right?
Ah, yeah.
Yeah, so this is your starting screen actually. So I already have some notebooks open. So that's good. So my question is like everyone is seeing at least this part. Like, I just want to confirm everyone is able to see this. So
Yeah,
that when
Not not so many things. In notebook, I can see Python 3 only.
yeah, that's fine, that's fine. Application error executing Jupyter command lab. Acha. So if you are getting that error, Junaid, can you try this? Can you try typing this command? So, localhost 8888 and then 3. Okay. Can you tell me if this is working for you?
This is notebook, right?
Oh, no. Junaid has some error. He's typed in the chat window. I'm explaining for him.
Notebook is able to launch, not the lab.
No, for no. What I wanted to do is I just want everyone to like when I say open a notebook, I want everyone to just start open and then uh,
Click on Python 3.
okay. So let's see how we can use matrices in NumPy. I hope everyone is got the home page, but not lab. Yeah. So whoever is not getting lab,
So I opened Jupyter Notebook, but I'm not able to get that.
yeah, that's fine. That's completely fine. So you just have to follow different steps. So you have to just click here Python 3. That's the only difference. Both of them are. So that is an installation issue that we can figure out later. Maybe towards the end of the class or maybe beginning of the class. So I think your Anaconda Navigator version might be different. So mine is 1.9.12 and I'm on Mac. I think you are on Windows, I'm assuming. So everything is same, only interface will be different. Every command, everything will be same. So for us, for you, whoever for whom lab is not working, you guys will write commands here. For whoever lab is working, you will write commands here. That's the only difference. We can figure out like why lab is not working for you. Okay. For now, yeah, for now.
So in that lab, you have clicked on notebook.
Yeah, so in the lab, so let's say in the lab, I click on this plus and I click on this Python 3.
Okay.
That is a long term. Now, how do I import NumPy? So the way import NumPy is import NumPy as NP, right? So what does as NP mean?
It's aliasing.
It's aliasing or write as a shortcut, right? So I don't want to write NumPy. I can write NumPy dot, right? So let's say, let me create this. So you guys can also follow along. You guys can also type along with me. Okay, so how do I find the shape? Okay.
And in that shortcut will be working like what we are using in Jupyter
Yeah.
notebook. Okay.
Can anyone explain me like what is going on, what I have typed here?
Created a 3 by 3.
First, you have converted that list to that one-dimensional array, means ND array, and then you are shaping it. Means you are checking that what shape it contains, means how many rows and column.
This is a row vector.
Hmm.
And so whatever I've explained till now in the concepts, I'm just trying to show you in the form of code. Okay, so this is a okay. Now okay. Now there are so many functions in NumPy, but as you go on practicing, you will learn more and more functions. Have you guys worked with this function called reshape?
Yes.
Yeah.
Right. So what am I trying
Yes.
to do here? Can anyone tell me?
So the row number and column number you have changed,
Okay.
and it should be equal to the number of elements. Means previously you have 3 plus 3 matrix, so the number of elements is 3 into 3 is 9.
Okay.
So, and the second matrix, that is 9 into 1 9, so that should be equal,
Okay.
otherwise we will get the validation error.
Okay. So basically what I've done is I've converted a 3 by 3 matrix into 9 by 1 uh, 9 by 1 column matrix. So as you can see here, when I print it, so this is a 1 column but 9 rows, right? But here I have 3 by 3. There are 3 rows and 3 columns. So like that, there are reshape, there is transpose. Let's see dot. What the syntax? Yeah, this is how you do a transpose of this. Now, what is the shape of this? This is 1 by 9. Okay. So C dot capital T means you're doing the transpose of the matrix, which is C over here. So this is a 9 by 1 matrix, which is a column matrix. When I do C dot T, this is a row matrix or a row vector. So this one is okay. Whereas this one is row. Okay. So like that, there are many operations, but I hope you guys can connect the dots here. So let's say if I define this, so one thing I want you guys to understand is the number of square brackets that are here. So I don't know if you can see this. Okay, the square brackets are important, right? So okay, so how many square? So this is basically a square bracket. I mean, like a list. This is basically a list, and there is a list of lists, right? So this is a list of lists. Right? I hope you guys can connect the dots here. Okay, so let me do this one. B equal to np dot a range shape. Can anyone tell me how does this D look like?
It's a three-dimensional.
It is three-dimensional. Okay. Any other answer? Like how does it look like? How do you visualize this?
Box.
The way you visualize this, So let's say these are your numbers. So the numbers are 0, 1, 2, okay, 3, 4, 5, and 6, 7. And then you have, let's say this is your building, right? So a building has floors, right? So let's say this is your building generally. Or let's say this is your draw, right? So let's say this is draw number 1. Let's say this is draw number 2, right? So in this draw, you can pull this out. When you pull this out, these are the values you see. And when you pull this draw out, so these are the values you see. Okay? When you pull this top draw out, these are the values you see. Now, how can I understand this money? So the way you can understand is, this is your one vector, okay? And this whole thing is your matrix, the red color one. The black color line is vector. This is a matrix. And the collection of matrices, this is called your tensor. Okay. Remember this notation. So this is called tensor. So this one is called tensor.
Only one doubt here.
Yeah, what is it?
When you in the first in the tensor, the first one, what you have written, what we have is 0, 1, 2, 3, 4, 5, 6, 7, 8, right? But when you pull the drawer, you said that 6, 7, 8 will be first. We will be able to see 3, 4, 5, 0, 1, 2. Just shuffled it. Why and how is that?
No, you will see. Okay. This is wrong. You will see in this format only. You will see like this.
I got it.
You got it, right? So
Next one, sir, is how is this tensor related to the tensor flow? What?
they got the words from this one. So whenever they were looking for a name, so TensorFlow is all about operations on tensor and in a graph. So that's the main that's the meaning behind the name of that framework. So the TensorFlow means there is a graph and there are tensors. So tensors will be flowing from the top to the bottom in your TensorFlow whenever you make any TensorFlow graph. Okay, so that's where they got the name of the TensorFlow framework.
TensorFlow in this?
Sorry?
Are we going to cover TensorFlow?
No, TensorFlow will be covered in your deep learning. We'll cover NumPy, Pandas, sklearn, time series. We'll cover clustering, and we'll cover basic statistics like hypothesis testing, then your Z-score, t-test, all that, ANOVA.
No neural network.
Basics of neural networks. The remaining part will be taken in your next class. So that will be taken by another professor. I mean, like another lecturer, so whoever is taking. Okay. So I hope you guys got the basics of it, like the basics of matrices. There are so many things, of course.
Mani, so the meaning of tensor is 3-dimensional arrays. What is that?
Four also. It can be 4 also.
So yeah, what's the basic meaning of tensor? Tensor means.
It means you have more than 2 dimensions.
Okay, so more than 2. Okay.
Yeah. So let's say this is vector, right? So vector is, let's say, 1, 2, and 3. So this has only one direction, one dimension. So matrix is basically 1, 2, and 2, 1. So it has 2 directions or 2 dimensions. So tensor is basically like this. So 1, 2, 1, 2, 2, 1. And then again you have like this. 3, 1, and 2. Don't get confused. So this is direction. This is one more direction, and this is one more direction.
So then tensor means n-dimensional matrices, correct?
Right. More than 2.
Okay.
Okay. You can also, after 3, you cannot visualize, but this is how a 4 will look like. But we cannot visualize, human brain cannot visualize more than 3 because we only see 3-dimensional objects. Okay, but mathematically and based on programmatically and all, tensors can be 4, 5, 6, 7, 100, 2000 also. Okay, 2000 dimension. Okay, anything more than 2 is called a tensor. Vector, scalar, actually I forgot scalar also. Scalar is basically nothing but a number. Like this is a scalar. Okay, number 6 is a scalar. This is called a scalar. Scalar, vector, matrix, and anything above this is tensor. Okay, anything above this is tensor. Okay, so all these operations that you can do with these matrices, all the things that you have learned can be done with the help of package called numpy. So numpy has so many functions. So the way you can figure that out is you can do dir and you can do np. So there are these many functions. Like it is impossible to remember or know all of these. Even I don't know all of them. So whenever there is any need, I will look for the documentation here. So I don't want you to remember. I want you to know how to figure out. So when you search for numpy documentation, okay, so this is where all the functions will be present. If you click on this, so let's say if you go to this, okay, let's say you want to find transpose. So I'm showing you how to uh, figure out the documentation instead of remembering the documentation. Okay, so you can do a dot transpose or you can do a dot t. Right. So let's say if you want to figure out standard deviation. So let's say you have these numbers 1, 2, 1, 2, and 3, 4. So you can figure out np dot std of a dot std. So like that, there are everything is present in numpy mode. Then there is median. Then there is percentile, quarter percentile, all those things you want. Everything is present in the form of numpy function. All the concepts that we learn in theory will be present as a uh, function here. So if you do len of this, you'll figure out I think more than 300 or 600 are there, 600 functions. So it's impossible to remember all those 600, but what you can remember is there is enough support in numpy functions that all the things that we learn in class, we will have a function corresponding to that. Okay. So I hope you guys got, we started out with expected value. So expected value is wherever there is some probability associated, there is an expected value. Expected value is nothing but the average or the ballpark figure that you can expect when you see that particular probability a lot of times, like many number. And if you keep on rolling a dice, you will end up seeing the number 3 and 4 more often than 1, 2, 3, or let's say 1, 2, or 4 and 5. We've discussed one more problem on the variable pay, which is basically what is the expected value of the salary at the end of the month, end of the year. Okay. After that, we have discussed the basics of matrices, vectors, then addition, multiplication, row-wise multiplication, row-wise division. Then we have looked at how can you multiply two matrices and how can you find the inverse of a matrix. Then we looked at Python code, the NumPy package. How can we create matrices, vectors, then a matrix and a tensor. Right? So this is a tensor. How do you find the shape of this? So the shape of this is 3 cross 3 cross 3. Okay. Now, I hope you guys were able to connect some of these things with the help of code and were able to understand the matrices and basics of linear algebra and all that. So with that, I'll close the class here today. If you guys have any other, I'll stick around for another 5 minutes.
Yeah, I have a couple of questions.
Yeah.
So first is that this document, can you please share with us the chapter on the metrics?
Chapter on metrics. Which one? The PDF?
The PDF file, yes.
Yeah, PDF I'll upload.
Okay. And another one is, will you be covering the data analysis, all these libraries right from the beginning, like NumPy, Pandas, all these?
Sorry, I didn't understand. NumPy Pandas?
Will you be covering these libraries from the beginning?
Yeah, we'll be covering, like, let's say if I
Okay.
correlation, then we will do some code on correlation so that you understand concept and you understand how to do it in code.
Okay.
We'll do code.
Oh,
We'll not.
okay. Actually, we have requested Krishna to take retake classes for these libraries. So I was wondering whether you are taking or someone else is going to take that. That's
That
why I was asking.
I'm not aware actually. We can
Okay.
do it to along, right? You don't have to worry about that. You will pick up slowly once we explain all these NumPy, Matplotlib, and
Sure.
pandas. We'll do
Oh,
enough code actually. If you want to figure out or what was done, let me share this. What was done in the previous classes. So this was on January batch. So we have went through all these codes together.
uh,
We're not
we are
able to
not
see a
able to
screen.
see your screen. Yeah.
My bad. So you guys can
Yeah.
see that. So let's say if
Yeah. Now we're able.
let's say if I explain k-means, right? So k-means example you can figure out, right? So we are doing code together. Let's say. So this code you can practice or you can actually. So this is an example of k-means, right? So here also you can learn like how these packages are working. We are using scalar, we are using pandas, we are using matplotlib. Okay, we are using functions like import, data frame, all those things.
Mani, can you paste this URL, GitHub's URL in the chat? Let's if you don't mind.
Yeah, I'll share this. Okay, any other questions, guys?
So these things we will be covering in coming days.
Yeah. We'll be covering concepts, and wherever we can do code, we'll do it code also. Okay.
Okay.
And also, can you share some assignment kind of things like you shared for yesterday for probability so that we get a hang of it? Like while you type, it should come on your hands, right? So,
Yeah. So matrices, I wouldn't say assignment, but I would say that you guys, if you can start your Jupyter notebook and just run few of the basic commands. For example, I don't know how many people know this. What does this A range mean here? Right. So I don't know how many knows this. How many people know this? But like this, there are many functions that are there in this. Right. So you guys can just practice the basic functions in NumPy. For example, uh, how do you find the standard deviation of numbers? How do you find the mean? How do you find the median? How do you find the 25 percentile? How do you find 50 percentile? If you can do this, that is more than enough, right? You will get a hang of NumPy and packages, and how do you do that in matrices, right? So how do you convert the shape of it? What is a reshape command? How do you find the reshape, right? So all those things, if you can practice on your own in your Jupyter notebook, then you will feel more confident on the bigger assignments. Let's say if I give you a credit card fraud application, or then these will be coming handy. Okay. Did I answer your question? Like what I'm saying is just practice the functions that we have discussed already. So some of the functions are mean, median, mode, standard deviation. You can learn about percentile, like what is a 25 percentile. These are all NumPy functions. So I have not even gone to pandas or sklearn. So these maybe 5 to 7 functions, reshape and a range. So all of these functions, if you are familiar with, that is enough for now. Slowly I'll tell more functions to practice.
okay. And the tensor that you showed, it was the size, the shape was 3 by 3 by 3. So if I had 3 by 3 by 2, how would I identify it?
How would I identify meaning?
I mean, is it 3 rows, 3 columns, 2? Um,
Yeah, it is 3 rows.
First is rows.
I wouldn't say rows, just for the explanation I'm explaining that. It is just a tensor actually, because if I say 3 by 2 by 15 by 3, so what does it mean here? Now we cannot visualize that, right? But just for the explanation purposes, I've explained that. So you can think of that in that manner, but tensor can be this. This is also a tensor. This is a 4-dimensional tensor, right? So for simplicity purposes, let's go with that. So this is rows and this is columns, and this is the 2 is basically the height. So what it means is you have a drawer where you have only two of them, like basically draw one, D1 and D2. So what is present in this is basically a 3 by 3 matrix. So 3 by 3 matrix here and a 3 by 3 matrix here. Okay. So just be careful, like when you're working with tensors, whenever you run this command, and when you do this, all you have to figure out is the number of squares here, right? So you have to be very careful, extra careful with here, right? So let's say if you do this, what is 29 of this? Right. So now this is a 4-dimensional. If you do this, this is a 4-dimensional tensor. Now we cannot visualize this anymore, like rows, height and width. We cannot, because there is a 9 in the end. So should I say that is a row or a height or a width, right? So we cannot visualize. But the way we can visualize is in this manner. So you can figure out the number of square brackets. So generally I try to understand from this. Okay, so these are the number of square brackets. So this is a collection of 3 dimensions, right? So let's say what it means is there is how many, 1, 2, 3, 4, 5, 6. So there are 9 of these. So let's say you can think of this. So there are 9 of these ones. So how many of them are 9? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now what are these? These are individually 3 by 3 by 1. So let's say this is 3 by 3 by 1. So basically this is 1 again. 1 is basically, this is a row. Right? Again 3 by 3 is basically 9 values are there. So 1, 2, 3, 4. But in simple terms, let's not go to 4 dimension, which we cannot visualize anyhow. But if I come back to your question, the way you can remember that is basically in simple terms. So let's say 27, right? So how you can do that? 27, 9, 9, 18. 18, and then you have 2. So you can visualize in this manner, right? So let's say there are how many? 1, 2, 3. Okay, so there are 3 rows. You can play around with this, then you will understand actually what is happening. So in this case, what is the answer? So there are 2 rows, then there are 3 columns, and there are 3 of these. 1, like this, there are 3, like 2. And you can also again play around with this. So if you go back to this one, so what is the difference here? There are 3 rows, 2 columns, and 3, let's say, height. Right? So you can play around like this and try to visualize. Is it clear? I mean, does it make sense?
Yes.
So you can play around with this command actually. You can play around and see like how things are changing. You can start trying to understand in the 4th dimension.
Okay. Thank you.
Okay, guys. So then I'll close the class here today. We are already
Next class, what we are covering?
next class. 1 second. Let me see your syllabus actually. I don't want to go off chart. Yeah, we can cover descriptive statistics. I think you guys covered descriptive statistics.
Yes.
So we can cover that. So you,
Not means not in this class. Means in the last class, the descriptive statistics that was covered.
what do you mean by last class?
Means by Ragini ma'am.
Okay, so I'll cover any. So I think I have to cover all of that again.
Yes, yes,
Yeah, that is
yes,
not clear
yes.
actually, the descriptive statistics.
Yeah, we'll cover descriptive statistics in the next class.
Yes, yes, yes.
Any doubt what we'll cover in the next? I am following this course structure.
Okay.
Course structure. So we have covered most of this here, like basics of linear algebra, matrices, vectors,
Mm-hmm.
multiplication of matrices, fundamentals of probability, probability distribution function, and cumulative distribution function. So first chapter of your statistics is done.
Mm.
Second chapter we will start, which is basically your descriptive statistics. How do you describe a data set? Central tendency, mean, median, mode, kurtosis, and skewness. Computing the standard deviation and variance. Types of distribution. Box plot. So box plot is important. Box plot, histogram. All these things we will discuss in the coming classes. Maybe I think it'll be classes.
Yeah, yeah. So my request from you that whenever that slight coding will also be there, then and you think that that you can explain this by coding, then please include that part as well, like today you did.
Yeah.
Uh,
I'll do that.
yeah, that's by that we can recall that all those functions and methods.
Yeah.
Yeah. Thank you so much.
Yeah. No problem. Okay, guys. I think I'll get back to. I'll close the class today here. Okay.
Thank you.